In other words, each equation of motion has only 4 out of 5 of the parameters of motion. And so this is the secret that you just need to know. Hello guys, I'm AppGenius and you're welcome to my YouTube channel once again. In today's video, we're going to be looking at the equations of uniformly accelerated motion part 2, because I had dropped a video on the part 1 of this topic, and just in case you've not checked it out, I will advise you do so, because the knowledge we gathered in that video will be very useful to the comprehension of this video. Now, today we're going to be looking at practice problems on equations of uniformly accelerated motion. We want to see how we can use these equations of motion, which we had derived previously, to calculate problems related to motion. Are we together now? Yes. In the previous video, I talked about the parameters of motion as well. So we're going to be using the knowledge of all of those to solve problems or to understand this topic fully. So the first thing I'm going to do, I'm going to write parameters of motion here. All right, parameters of motion. All right, next I'm going to write the equations of motion, which we have already derived. Please, equations of uniformly accelerated motion, but I'll just abbreviate that. Okay, now the first equation of motion that we derived was V is equal to U plus AT, and then the second, S is equal to UT plus half AT squared, and then we have V squared is equal to U squared plus 2AS. Are we following now? Then I added S is equal to open bracket V plus U over 2 close bracket T. This is the fourth equation. However, these are the three major equations of uniformly accelerated motion. Now, the parameters of motion that I listed in the previous video were distance, and we noted that distance is denoted by S. So S is distance, and then we have time, all right, T, and then we have initial velocity U, and then we have final velocity V, and then we have acceleration A. So let me number them. We have 1, 2, 3, 4, and 5. So we have 5 what? Parameters of motion. You can call this STU-VAR. All right, STU-VAR. It can help you to remember them. So these are the 5 parameters of motion that we discussed in the previous video. Now, for us to solve problems on equations of uniformly accelerated motion, we are going to be looking at how to choose among these equations the suitable equation that can help us calculate or solve the problem that is given to us. So is it that if they are given a question, we just choose arbitrarily, maybe this third equation or this one? No, we are to find or to know how to choose either of these equations for a given question. And so there's a secret to that. The first thing you have to note is that we have 5 parameters of motion. However, looking at these equations of motion, if you take a careful look at each of them, you will understand there is something spectacular among them. And if you are very observant, you will be able to see that out of the 5 parameters of motion that we have, only 4 are contained in the equations or in each equation. In other words, each equation of motion has only 4 out of 5 of the parameters of motion. And so this is the secret that you just need to know. And if you know this secret, it's become easier to choose the right equation. And so let's now analyze each of these equations. If you check carefully, this has B, U, A, and T. Can you tell me which of the parameters of motion that this does not have? Yes, that is what? S. So this has no S. Now this has S, U, T, and A. T is also here. So can you tell me which of the parameters of motion that are here that this does not have? Of course, you are right. That is V. So this has no V, right? What of this? VUAS. This does not have T. So I'll write no T as well. And if you want to check this SVUT, this does not have A. Are we following? So this is the first secret you need to know that you have not been taught. Yes, as simple as that. This is the first thing you have to know, because this will guide you. Now, what this goes to tell us is that whenever you are calculating a problem that you are required to calculate distance, or you are given distance, you cannot just make use of this equation because it does not have distance S in it. So if I want to calculate for distance, this equation is wrong for me to use. Furthermore, if I want to calculate for final velocity V, or I'm given final velocity V, I cannot use this equation because it does not have final velocity V. So this is wrong when I want to calculate for final velocity V. If I also calculate for time, this equation will be a bad idea to use because it does not have T with it, and this does not have A with it. Are we together? But then something is also very common among all of them. And what is it that is common among them? If you check carefully, initial velocity U is everywhere. Can we observe that? It means that if you are looking for initial velocity, you can use either of these depending on the other parameters that are given to you as well. So initial velocity is very common, is in all of them. Are we together now? Because we're looking at equations of uniformly accelerated motion. So that object that is undergoing uniform acceleration must start its motion with an initial velocity. Are we following? So this is the first step that we need to make in solving problems on equations of uniformly accelerated motion. All right, now having looked at the first step in solving problems on equations of uniformly accelerated motion, which is to know how to find the formula to use or the equation to use out of the four equations. All right, we are moving on to some rules that will be helpful in understanding how to solve problems on this topic as well. And Map Genius, as always, have prepared some rules for you. So some Map Genius rules for equations of uniformly accelerated motion. All right, you don't have to cram these rules, you just need to know them. In fact, these rules becomes the concepts, because to solve problems in physics you need concepts, not just theory. You need to know the rules that guide that particular topic. If you can know the rules that guide the topic, it becomes easy for you to solve problems on that topic. Yes, and so I have decided to make these rules for you so that you just know them, not to cram them, but just understand them and to be helpful. Now, the first thing you have to note is that you have to list the parameters given to you and the ones that you are asked to calculate for in the question. Okay, so you just go like given. All right, you're writing out the parameters given, you are given this, you are given that. Are we together now? And please, you also have to make sure in listing out this that all the units are homogeneous, or let me say all the units are the same. For instance, we're talking about let's say velocity, and you're giving velocity in meter per seconds, for maybe v, and they're now giving also in kilometer per hour. No, you have to convert to make sure that there is a common unit for a particular quantity. Take note of that. Are we together now? All right, having said that, the next rule is choose the appropriate equation from I above. When you list the parameters given to you and calculate, and the one calculated for you, observe that the ones given to you probably be 3 and the one calculated for will be 1, making it 4. Remember that each of the equations have 4 parameters, and so if you can list this, you will not know the appropriate equation that you can use to solve the given question. And then number 3 is when an object starts from rest, u is equal to 0. Now sometimes they might not give you u, you might even be wondering, students keep wondering, they not give me u, now they not give me v, how do I solve the problem? They only gave me time. But you don't know that from the concept, from the question, they have given you the values of some things. Now in physics, sometimes we don't give values by writing them down. Some values are implied, some values of some quantities are implied in the course of giving you the question. So if in case you are solving a problem and you now see a body starts from rest, that has automatically made initial velocity u to be equal to 0. Are we following now? So when an object starts from rest, it means that that object, the initial velocity of it is actually what? 0. And if it starts from rest and start moving, it means that it actually accelerates, and so we have positive acceleration. Are we together? Now the value of acceleration will be positive. That's the meaning. Then another question you can have, that an object comes to rest. So when an object comes to rest, final velocity v is equal to 0. Take note of that. So you must not be giving the value of this and this. Sometimes it can be implied. So when you hear comes to rest, that tells you that v is equal to 0. And if something comes to rest, it means that it was moving with a higher speed, but then its speed now decrease, and decrease in velocity, or velocity is actually deceleration or retardation. So when an object comes to rest, it is reducing its velocity, and so it decelerates, and the value for acceleration will be negative. Are we together? And then also when brakes are applied, the object also decelerates. Of course, when a car is moving and you apply brakes, you see that the car will now want to stop. Okay, the car will now reduce its velocity, and that is also deceleration. So these are some of the Mabinius rules that I can write out for now for you, and I think this will do for you to solve problems on equations of uniformly accelerated motion. Now, having said all of this, let's now dive into the problems. Let's say you came across this question in your JAMB or in any examination, and you are asked to calculate the acceleration of a car, given that the car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. It is very simple. The only thing you need to do is to follow the rules that I have given. Now, let's write solution. The first thing to do here is to write out the parameters given to you, because anytime you come across this kind of question, a car moves with this, that, you have to use the equations of uniformly accelerated motion. Are we together? So what's the first thing given to us? You are given initial velocity is what? 25 meters per second. So u is equal to 25 meters per second. It's the same thing. All right. Next, final velocity v is equal to, because they say and reaches a velocity of 45 meters per second. Any velocity after initial becomes final. So this becomes what? 45 meters per second. Are we following? Then they said that this movement was done in time equal to 10 seconds. And then we were asked to calculate acceleration A. Now, have you now seen that these parameters, the one given to me is 3, and the one I'm looking for is what? Is 1. Are we following now? And so that makes it possible for me to get an equation to use. Now, out of these equations, v is equal to u plus at, s is equal to ut plus half at squared, and then v squared is equal to u squared plus 2as. Which one can we possibly use? Is the one that actually has all of these parameters here. So you can see that first one has v, it has u, it has a, it has t, and so that's the appropriate equation to use. So now we just use the equation. So we're going to write that v is equal to u plus what? At, and then we'll just substitute the value. What is v? V is 45 equal to, and what is u? U is what? 25. We bring down plus. We are looking for a, and then at means a times t. So what's our t? Our t is 10, and so we'll just go ahead to finish up. So let me divide here as well. So we now have this to be what? 45 is equal to 25. A times 10 is 10a. Now we are going to subtract 25 from both sides, or you say move 25 to this side because negative. So we have that 10a is equal to 45. This is now minus 25. I hope you get it. So now have 10a is equal to 45 minus 25. Horizontal subtraction. 5 minus 5 is 0. Then 4 minus 2 is 2. So it means that 45 minus 25 is what? 20. We divide both sides by what? 10. And then 10 cancel out 10. We have that a is equal to what? Obviously 2. And what's the unit of acceleration? That's meter per second squared. And that's the answer to this question. Question number 2. A car accelerates uniformly from rest at a rate of 3 meters per second squared. What is its velocity after traveling a distance of 24 meters? Just in case you come across this question, it's very simple to solve. Are we together? And so let's dive right into it. Now, the first thing you have to do is to write out the parameters of whatever is given to you, taking note that some of the quantities or the parameters will not be given, but they will be implied. Their values will be implied. Are we together now? So look at the question now. A car accelerates uniformly from rest. So this from rest tells us something, that if something starts from rest, its initial velocity u is equal to 0. And so that means because of this, rather u is equal to 0. Now a bit confusing, right? Because nothing like u or initial velocity was mentioned, but they have given it to us because of these words we have. From rest is a rate from rest, so u is equal to what? 0. Then at a rate of 3 meters per second squared. Now even from the unit, I know that this is acceleration, but they say a car accelerates, so this is my acceleration a. So they give me a to be equal to what? 3 meters per second squared. And then we are asked to calculate the velocity after traveling a distance of 24 meters. So s is given to us, and that's distance 24 meters. But then we are asked to calculate what? Final velocity v, and that's what we don't know. So if you also take a careful look at this, you see that we also have 4 of the parameters of motion, making it fitting to pick any of these equations. Are we together now? So let's now check which equation will be appropriate for this particular question. Now the first one has u, good, has a, has time, but there's no time here, so this equation will not go for this. So let's look for the equation that does not have time, because obviously what is not here is time. So which one does not have time? Obviously is this. This does not have time. So we're going to use this equation. So we're going to lift that equation. V squared is equal to what? U squared plus 2as quickly. And then we're going to substitute the values of everything we are giving. Alright, V, we're looking for V. So we retain V. V squared is equal to, what's our U? This is U, and U is 0. So write 0 squared plus, then we have 2. 2as means 2 times a times s. So this is 2 times plus a, 3. What's s? 24. Are we following now? And so the next thing to do quickly is to simplify further. So you have v squared is equal to 0 squared is 0, and 0 is nothing. So the next we're going to do that, we're going to say 2 times 3 is 6. Now 6 times 24. I'll just go to tell you the answer is 144, but let's just get it. 6 and 24. Okay, let me do with that. This is 6. So 6 times 4 is 24. Alright, 4. And carry 2. Then 6 times 2 is 12 plus 2. That's 14. So 2 times 3 times 24 is 144. And so we have v squared is equal to 144. To get v, we take the square root of both sides. Alright, in physics you don't need to put plus or minus, just put it 144, and v is equal to, because the square root of 144 is 12, and what's the unit of velocity is meter per second. That becomes the answer. Question number 3. A car accelerates from rest and moves with uniform acceleration of 30 meters per second for 20 seconds. calculate the distance covered at the end of the motion. Just in case you come across this question, super easy. Just follow me and we'll arrive at the answer safely. Are we together? All right, so let's dive right into it. Solution. As we always do, we're going to write out the parameters given in this question. So let's go. A car starts from rest. That phrase, starts from rest, tells us that u is equal to 0. Initial velocity u is equal to 0. Are we together now? And moves with uniform acceleration of 30 meters per second squared. So a is equal to 30 meters per second squared for 20 seconds, and of course anything in seconds will mean to be time. All right, and then we are asked to calculate distance, and distance is s. We are looking for it. So you can see, even from the first second questions, you can see that everything they are giving to us are 3, and they are looking for 1, making everything to be 4. So, and I told us that each of these equations has only but 4 of the parameters, and so you can use any of them that is appropriate for a particular question. So we'll look at what is not here to check what equation we are going to use. So UATS, that means V, final velocity V, is not here. So let's look for the formula that does not have final velocity V. Obviously this is V, this is V, so this does not have V. So we're going to use this equation. So we'll copy it out. S is equal to UT plus half AT squared. Are we following? And so the next thing to do is to substitute our value. So we're going to say S is equal to, what is U? U is 0 times, all right, UT means U times T. So U is 0. So 0 times, what's our T? T is 20, then plus half, which is a constant, times, because half 80 squared means half times 80 squared. And so A is what? 30, then times T. T again, T is what? 20, and obviously is squared. Are we together? So let's simplify. 0 times 20 is 0, because 0 multiplied by anything is 0. So we have S to be equal to, this is gone. We have half times 30 times, let me write this again, 20 squared. All right, so we have S is equal to half times 30 times, what's 20 squared? 20 squared means 20 times 20. Are we following now? 20 times 20. So keep the 2 zeros. You have 2 times 2 is what? 4. Add the 2 zeros, you have 400. So 20 squared is what? 400. And so we will go ahead to simplify further. So I'm going to cancel out. This, all of this will be over 1. So this will be 2 here, 1, and this 2 here is 2. So S becomes equal to, keep the 3 0. Okay, let me write it out. 30, because this is 1 times, everything is 1. 30 times, then we have 200. And then X is equal to, keep the 3 zeros. All right, so 3 times 2 is 6, and then you add the 3 zeros. You have to be what? This. So it means that S is 6,000 meters. We can also decide to write it as S is equal to 6 kilometers, because 6,000 also means 6 times 1,000 meters, and 1,000 meters is kilometer. So this is our value. Any of this is our value. Question 4. A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that has just turned red. If he just reached the traffic light, his deceleration is A, 5 meters per second squared, B, 9 meters per second squared, C, 10 meters per second squared, D, 80 meters per second squared. And so, in case you come across this question, you don't need to be afraid. It's very simple. The first thing I have to do in this question is to analyze this question. Now, imagine that, let's say a motorcyclist traveling at this speed starts to apply his brakes when he's 50 meters away from the traffic light that has just turned red. And we all know that when a traffic light turns red, it means stop. So let's imagine that the traffic light is somewhere here and it have turned red. I'm sorry, I'm not with a red marker to illustrate that. Okay, and then this is the line which the road users are going to be stopping before they move on. So let's say the motorcyclist is here. Let me draw this. I hope you just get me. All right. So this is the motorcyclist. Now the motorcyclist was traveling with the speed, that's the initial velocity, to be equal to 30 meter per second, and he was actually 50 meter away from the traffic light. Are we together now? And then immediately he was moving with this speed, and he now observed that the traffic light had shown red, so he started applying his brake. Now when you apply a brake, you don't automatically stop. That's it. Especially when you're in a high speed, you don't automatically, when you apply a brake, you stop at some distance. So he applied his brake when he was 50 meters away from the traffic light. Are we together now? So you can now see that when he finally reaches here, he's going to stop, and that means that the final velocity will be equal to 0. Are we together? So that means that he actually his velocity actually decreased. Are you following now? So that is deceleration. All right, so we're going to be using this analogy to solve the problem. Are we following now? So let us write down the things that we are given if you actually understood this analogy. Are we following? All right, so let's now solve the question. Solution. So from the question, we have that u is equal to 30 meter per second, because that's the first velocity given to us before the motorcyclist came to rest by applying brakes. And then we are also given that the distance s is 50 meter. All right, and then we are asked to calculate his deceleration. However, we know that he will reach the traffic light, that means he will stop. So v will be equal to what? 0. And the acceleration is what we are looking for. Note that the acceleration will be negative. Are we following now? When it has to do with deceleration, is either you change these positive values to be negative, or you just solve but you will get your answer to be negative. Anyone. So it's either I use these equations but remove this positive sign to be negative, because acceleration is also common here. All right, then I'll just get positive value, but if I solve it direct, I will get negative value, suggesting to me that my acceleration is what? Negative, meaning that it is deceleration. So we don't know what the acceleration is, so let us go ahead to just solve the problem with this equation direct, so that we can get negative value. So which of these equations will be appropriate for solving this problem? All right, so you have v is equal to u plus at, then s is equal to ut plus at squared, and b squared is equal to u squared plus 2s. All right, so which of the parameter is not here? We have u, we have s, we have v, and we have a. So obviously time is not here. So let's look for the equation that don't have time. So this does not have time, so we'll bring it out. V squared is equal to u squared plus 2as. Are we following? Yes, v squared is equal to u squared plus 2as, and so substitute the values of what we have. Now we know that v is 0, so write 0 squared is equal to, what's our u? U is 30, and 30 is already squared. All right, then we have plus 2 times, what's our a? That's what you are looking for, times, what's our s? Our s is 50, so write 50. Are we following now? So 0 squared is 0, and so 0 is nothing. So maybe let me write here to 0 is equal to, all right, so we have 30 squared. 30 squared means 30 times 30. So we're going to keep the 2 zeros and multiply the 3. 3 times 3 is 9. Add the 2 zeros. All right, so we have this to be what? 900 plus, now 2 times 50 is 100. 100 times a is a. 100a. 100 times a is 100a. And now we're going to move 100a to this other side to collect like terms. Are we following? So we have, but to move this over, it becomes negative. So we have minus 100a is equal to 900. And so we're going to divide both sides by what? Minus 100a, which is the coefficient of a. So this will become minus what? 100a. And this will cancel off, and then we have our a to be equal to, now plus divided by minus is minus, so these zeros will cancel out. Obviously we have it to be 9. Minus 9 what? Meter per second squared. And so we go to our options to take the correct answer. Option B is 9 meter per second squared. But you'll be wondering, but they gave us positive, so we know that acceleration is negative because it's deceleration. So this negative value is telling us that it is deceleration, and what we are asked to calculate is what? Deceleration. So don't mind the sign, just pick the magnitude of the quantity, and that's 9 meters per second squared. That is our answer. Question number 5. A body starts from rest and moves with uniform acceleration of 6 meters per second squared. What distance does it cover in the third seconds? And we have this option. Now, this question is very tricky. You have to be very careful of it. Whenever you see third second, whenever you see, I think these are called ordinals in English language, I think so. When you hear second, that's when the distance it covers in the second, or in the third second, or in the fourth second, or in the fifth second. Take notes. Are we together now? So if I'm asking you what is distance cover, let's say an object, all right, moved from this point, all right, to this point, then to this point, then to this point, and then let's say that these are points A, B, C, and D, and this is 0. This the first second, second this is the third second. Are we together now? And so look at this. If I'm asking you the distance covered in the first second, I'm asking you to calculate the distance between 0 and 1. That's what I'm asking you to calculate. Are we together now? If I'm asking the distance covered in the second, it is between the first second and the second. Are we together now? If I ask you to go the distance between the distance covered in the third second, it is between the second and the third seconds. Are we together now? Take note of it. So we want to solve this problem because third second is mentioned. We need 2 distances. Are we following? The distance between this and this is actually the distance of this minus the distance of this. So to calculate this question, we need to calculate the distance traveled when time was 3 seconds, and then the distance traveled when time was 2 seconds. Then we subtract it, and then we now get the distance traveled in the third second. I hope we understand this. Are we together? So please, whenever you see third second, fourth second, fifth second, it is very important that you understand that you need to calculate 2 distances. Are we together now? The distance when the time is 3 seconds and then the one below it. Okay, so if you are asked to calculate the distance in the fourth second, you need to calculate the distance when time is 4 seconds and calculate the distance when time is 3 seconds and then subtract the both. Are we following now? So having said that, let's quickly do that. So we are also going to use the equations of uniformly accelerated motion. So we have this solution. So let's get the parameters given to us. A body starts from rest. Here again, starts from rest quickly. U is equal to what? 0. And moves with uniform acceleration. So A is equal to what? 6 meters per second squared. Then we are asked to calculate what distance it covers in the 30 seconds. So it means that we are looking for what? S. However, we are given to calculate the distance in the 30 seconds. So we're going to take the first case. Okay, so case 1 is when what? T is equal to 3 seconds. Are we following now? So we use this equation. Which one are we using? We have U, A, S, and T. Means that the only parameter that is not here is V. And which of this equation does not have V? Obviously, this does not have V. There is V here, but there's no V here. So we will now start. Are we following? By using that equation, S is equal to UT plus half AT squared. Are we following now? Quickly, what is our U? So S is equal to, what is our U? U is 0 times, what is our T? 3 plus half times, what is our A? 6 times time. And our time here also is 3 squared. All right. Now 0 times 3 is 0. So we have that S is equal to half what times 6. 3 squared is what? 9. And so 2 here is 1, 2 here is 3. 3 times 9 is 27 meter. This is the distance this is the distance when time is 3 seconds. So case 2 is another you need to get, that when what? Time is 2 seconds, because we are asked to calculate distance in the 30 seconds. Calculate the distance when time is 3 seconds, then calculate distance when time is below, just 1 below the second mentioned, that's 2 seconds. So we also use s is equal to, now s equal to ut plus half at squared. So quickly from here directly, okay, let me see, write it, ut plus half at squared. Are we following now? And so s becomes equal to, u remains 0 because it starts from rest, times, then our time in this case is 2 plus half times, what was our a, our solution is 6, then times 2. Now t becomes what, 2, and is squared. So s is equal to, this is 0 because 0 times 2 is 0, and so we have that this is what, half times 6, then times 2 squared is 4. All right, so 2 here is 1 and 2 here is 2. 6 times 2 is what? 6 times 2 is 12, and you have 12 what? Meter. So let me call this time 3 seconds, distance when the time was 3 seconds, then distance when the time was 2 seconds. So for us to get the distance covered in the 3rd seconds, we're just going to do distance covered in the when time was 3 seconds minus distance covered when time was 2 seconds. And obviously this is what, 27 minus, what is this? This is 12, and 27 minus 12, 7 minus 2, horizontal subtraction, 7 minus 2 is what, 5, and then 2 minus 1 is 1, and that's meter. So this is our answer, and let's check which option has it. 15 meter is our option, is our answer, and option A gives us the correct answer. So some students might be thinking the answer will be 27 meter because they will just dive right into the question or the calculation by using time 3 seconds. Are we following now? No, that's not the right thing to do. Whenever you come with this ordinals, 3rd, 2nd, 1st, 5th, 6th, 7th, take note of it. You have to do it this way. Calculate the distance in that particular second mentioned. Calculate the distance again in 1 second less than that second mentioned, and then subtract the 2. That will give you the distance covered in the 3rd seconds. Are we together? So this is our right option.